Good morning and good day to the listener. We would like to present you about the research about message queuing telemetry, transport-based Internet of Things modeling for automatic oyster mushroom cultivation. The background of this research is one fact about Indonesia, which is an agricultural country which produces many products such as rice, corn, and many more. One of the most known products in this country is oyster mushroom. So, what's special about oyster mushroom? Oyster mushroom is a fungus kind of plant which has many benefits in nutrition for especially for replacing red meat. Yeah. So this oyster mushroom has capabilities to substitute the red meat for someone who in red meat diet. Since this mushroom has many good nutrition for them. However, the oyster mushroom has quite strict requirement for the growth, especially for the humidity and the temperature. Hence, the oyster mushroom must be cultivated in high elevated land, not in lowland, since in the high elevated land, the humidity and the temperature is good and controlled. However, the weather in high elevated land is quite uncertain, hence the farmer must control it properly, regularly, especially in daily time. The farmer must water the mushroom to keep the humidity, using the fan to blow out the heat inside the cultivation, and this is become a problem when the farmer has a wide area of the cultivation. Hence, our research has offered a solution where Internet of Things become a solution for regulation the condition inside the cultivation, especially for the humidity and the temperature. Many information inside the cultivation will be transferred into the central server via message queue telemetry transport as communication from the IoT device to the farmer by using many devices. In this research, there are exactly around five research regarding the automatic cultivation control. The first one by Triatanto, where using Atmega-based circuit to control the cultivation. The second one is by Ginting and Cynthia, where cultivate by controlling the humidity and the temperature inside the cultivation. The third one is by using fuzzy logic based cultivation control. The fourth one is using IoT based. And the fifth is using PLC based cultivation control. However, from the most exactly state of the art of the previous research has similar weakness where the HT22 sensor were not utilized. And the information to broadcast inside the cultivation is still using the classic one, not using message queue telemetry transport, where this protocol is has many benefits, including lighter communication, lighter packet size, which is easily transport via any medium, especially for wireless. Hence, in for this research, we have been proposed our solution by using this model. This model utilizes the HT22 sensor to detect temperature and humidity inside the cultivation, and we are using MQTT protocol as communication media to all platform, especially for smartphone, PC, or any web service which capability to process MQTT communication. package. This model offered automatic control where when the temperature or humidity reach certain threshold, for example, the temperature reaches beyond 30 degree Celsius, then the IoT device will automatically turn on, activate the fan to blow the heat. Another example about the pump to control the humidity. When the humidity below 75% relative humidity, the IoT device will automatically activate the pump to water the cultivation. This process will repeat endlessly until the interruption happen. For example, power interrupt. When the power interrupt, automatically the system will finish. When there is no interruption, especially power interruption, the process will continue. The IoT device will control automatically and will upload the data into the server. We have been proposed a curtain server which capable to store MQTT data, MQTT information from the device into the client. This server acts as broker instead of server. The board itself, the IoT board, will act as publisher where they will publish every information every second from the cultivation into the client. This client will act as subscriber which receives the data from the broker, and this PC or the client will receive the information every time the IoT board publish the information to the broker. Similar to the process previously, this process will repeat endlessly until the interruption happen in IoT board or in the broker or in the smartphone or the client. So the client will keep receiving the information from the IoT board until the interruption received or the interruption happen. The next slide, in this slide, we will explain the result of the detection of the model. The first left, this graph is show how the temperature happen from time to time. We are taking sample from 20 hours sample of detection and make a graph of it. According to the graph, the lowest level of the temperature is around 29.6 degrees Celsius and the highest point of this temperature is 30.6 degree Celsius. The next graph beside the temperature is the humidity. In this humidity is a sample for 20 hours exposure of the sensor. In this graph, the lowest point of the humidity is around 68% of relative humidity and the highest point of this humidity is around 78% relative humidity. This is the result of temperature and humidity detection from MQTT protocol. This device receives the information from the IoT board every 10 seconds according to the configuration of the publisher. How we can set up minimally 5 seconds or 1 second. However, since we would like to monitor 20 hours, we set our server or device to at least 10 seconds of detection. The next graph, this is tell how the fan and the pump activated during the activation of the model. The left side of the graph is how often the fan activate by the system, by the model. In certain time, the system turn the fan quite often instead the turn out of one. You can see from the graph eh, around from 2 p.m. until 9 half p.m. the fan turn it on and then turn it off and then turn it on again till 4 in the morning. This is one caused by the environment from the inside the cultivation. Then the right one is the how often the model activate the pump. The pump activate at 2 p.m. till 4:30 p.m. and then turn it off till 22 or 10 p.m. Then turn it on again and turn it off again. This graph is affected by the external factors such as environment or how the condition inside the cultivation. So this is proof that the model is working to detect the temperature and humidity inside the cultivation and capable to regulate and control by using fan and the pump inside the cultivation. That's all from our presentation today. I would like to thank everyone for the collaboration from the farmer to the researchers and many more. Thank you and see you again.